Today we're going to look at the compacted algebra and equations practice test and go through the solutions. So the first question, we're being asked to complete the question on the graph paper that's provided in the appendix. So we need to make sure we do it there. It says graph the following linear relations. Obviously one of them isn't linear, so we need to just remember that sometimes there are errors on a test paper or to ask questions about that in the exam. On the Cartesian plane provided, we're given two relations. One is linear, one is quadratic. So one we'll need to look at linear ways to graph that, and one we're going to look at how we would graph a parabola. So for the first equation there, 2x minus 4y equals 12. We can manipulate this to get it in the format y equals mx plus c. This is one way to solve it. There are many ways that we can solve this. This is only one way. I'm going to show you now. So if we manipulate it by subtracting 2x from both sides, take away 2x, we get negative 4y equals negative 2x plus 12. And then if we divide both sides by negative 4, then we're going to get this in the format of y equals mx plus c. Now we need to divide the whole side by negative 4. So that means dividing negative 2x by negative 4, which means I'm going to get 1/2 x and 12 divided by negative 4 as well, which means I'm going to get minus 3. Now you can see we're in the format of y equals mx plus c. That means the gradient is 1/2 and the y-intercept is negative 3. It's going to be at 0, negative 3. So this is one way to solve it. Another way to solve it is we can substitute in two values of x and y. We could try substituting in x equals 0 for the y-intercept and y equals 0 for the x-intercept. Unfortunately, and you'll see in a little bit, that won't work for this question so easily because of the graph paper that we've been given. But you could substitute in any two values and get the x value and y value. It's easier to manipulate, but you could substitute in and then solve the equation using algebra. So let's have a look at graphing this equation now. Now, our equation is y is equal to 1/2 x minus 3. That means our gradient is 1/2 and our y-intercept, our value for c, which is our y-intercept, is negative 3. That means we can plot the point 0, negative 3 on our graph paper. We can then use the gradient, which is rise over run, to move along by 2 and up by 1. A run along by 2 and up by 1. We can plot those 2 points on our graph, and I've done so here. You can see I've plotted one point at 0, negative 3, the y-intercept, and then I've moved along by 2, here, and up by 1, because that's our rise over run. Rise is 1, run is 2. And then once I've done that, I'll just remove that there. Once I've done that, I can join those 2 points together with a straight line. I can add arrows on the ends to say that equation continues on, and I can label my graph with the original equation 2x minus 4y equals 12. Now the reason why finding the x and y-intercept isn't going to work is we can find the x-intercept easily enough. Substituting in x equals 0, we get y equals negative 3. But what happens if we substitute in y equals 0? If we substitute in y equals 0, we get 2x equals 12, which means x equals 6, and x equals 6 is somewhere over here on the graph, and we don't know exactly where it is on that graph paper that we've been given, so we're not going to be able to easily plot that accurately. So we need to find another point. So what we could do is find a y value, or even look at what is the y value when x equals 3. So I could say, rather than trying to find the y-intercept, I want to find, the x-intercept. I can find 2 points. I'm going to find the y-intercept. I'm going to find, a second point, 2x minus 4y equals 12. I'm going to find a point where x equals 3. So the point where x equals 3 is going to be 2 times 3 minus 4y equals 12. So that means I'm going to get negative 4y is equal to 6, because I'm going to do the 2 times 3 and subtract 6 from both sides. And then I get y is equal to negative 3 over 2. Negative 3 over 2 is negative 1 1/2, and I can see that point on the graph is here. Okay, so I can see that that point lies on the line, and I could use that point just as easily as I've used the point 2, negative 2 that I've plotted there as well. So that's how we can find our graph for our first linear relation there. Now for our parabola, what we need to do is we need to substitute values in. So if I substitute in the value negative 3 into the equation, I get negative 2, y equals negative 2 times negative 3 squared plus 1. Now we need to be very careful substituting negative values in, because a negative times a negative is a positive. So negative 3 times negative 3 is positive 9. Positive 9 times negative 2 is negative 18. Negative 18 plus 1 is negative 17. If I put that into the calculator, I'll get negative 17 out, and you can see here. Now that point is not on our graph paper, so we can't plot this point. We can't plot 3, negative 17 either, but we can plot everything in between. We can plot 2, negative 7, negative 1, 1, 0, 1, 1, negative 1, and 2, negative 7. So if I plot those points in green on my graph paper here, you can see them plotted on my graph. Now I need to join them with a smooth curve, a nice smooth curve. If I join with nice smooth curve there, I need to make sure I put arrows on the ends to show that it continues in both directions, and then label my graph as it is given to in the question. Negative 2x squared plus 1. And that's how we've graphed our parabola there. Question 2 looks at finding and determining the distance between 2 points, the point midway between 2 points, and the gradient of the line. So let's have a look at doing A first, the distance between the 2 points. We can use our distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the square root of all of that. Substitute in our values. So x2, we can take this as point 2, p2, and this can be let's give it a better notation, p2, and let's call this point p1. Okay, so point 2, our x value there is 3. Point 1 is negative 2 squared, plus our y values are negative 4 minus 6 squared, and we get the square root of here 5 squared plus negative 10 squared. So I get here 5 squared is 25, 10 squared is 100, negative 10 squared is 100. So I get here the square root of 125, which ends up being about 11.18, I believe. I'm just going to double check that on my calculator. Yeah, 11.18 there. So that's the distance between the 2 points, 11.18. So if we look at B now, we're looking for the midpoint between the 2 lines. Our midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. We're finding the average of the 2 points. So x1 I said was negative 2, x2 is 3 over 2, oops, and y1 is 6, and y2 is negative 4 over 2, and so I get, what's that, positive 1 1/2, that's going to be 1/2 here, or 0.5, and then I get 6 plus negative 4 is 2 over 2, 1. So that can be as 0.5 or 1 as well. 1/2 and 0.5 are exactly the same. So that's our midpoint between the 2 points. Lastly, C, the gradient of the line. We know the gradient is rise over run. So the rise that we have is, or we can say delta y over delta x, y2 minus y1 over x2 minus x1. So the difference between the y values, we've got -4 minus 6 divided by 3 minus -2, and I get -10 over 5, which is equal to -2 as my gradient there. Question 3 says, I've got a triangle that's got side lengths 5, 12 and 13 centimetres. Decide if the triangle is a right angled triangle and justify your reasoning. Well, we can draw this. We could draw it to scale to try and look and see if it would make sense. Maybe do a bit of a better hypotenuse there. Oh, still pretty bad. Oh, could have done a better right angle too. There we go. And if this is 5, this is 12, this is 13, we're asked if it is a right angled triangle. If it is a right angled triangle, it will conform to Pythagoras' theorem. So c squared equals a squared plus b squared. Now you'll notice I've labelled 13 as the hypotenuse here. The reason for that is the hypotenuse is always the longest side. So if it is true, then 13 centimetres is going to be our value for c. So we can check and see if that's true. 5 squared plus 12 squared is 25 plus 144, which is 169, which is equal to, which means that c is equal to 13. Tick. That is the side length of our hypotenuse. So we need to justify our reasoning. So we can say, therefore, the triangle is a right angled triangle as it conforms to Pythagoras' theorem. So we should mention Pythagoras' theorem in our answer. Question 4, we're looking at our modelling and problem solving question here. Now, we need to remember what our strategies are for our modelling and problem solving questions. So I'm going to try and do this question using 2 methods and see if either of those can help you when you're actually solving your problem. So the key information that we have is that we've got our steps being 13 centimetres high and 23 centimetres wide. We've got a wheelchair ramp that needs to be constructed to reach a platform that is 4 steps above ground level, and the gradient needs to be 1/2. We can draw a diagram of our steps. We've already got a diagram given there. If I've got my steps, they're going to be a certain level that are high. So they're going to be going up and up and up and up and up, 4 of them here. And the height is going to be 13 times 4. Because each one's 13 centimetres high, and I'm multiplying them by 4. So that's 52 centimetres in total. 52 centimetres in total. Now, the wheelchair ramp that we're going to have needs to go from the top of the stairs all the way out. And we need to find out how far it's going to go out from the steps. We need to, essentially now, we can draw a right angled triangle that shows this relationship. We've got our ramp. It is going to be 52 centimetres high, and it is going to be some distance there from the top of the ramp, and that makes a right angled triangle. Now we know that the gradient of this line is 1/12. That means that rise over run is equal to 1/12. We know the rise that it has to go up is 52 centimetres over the run. Now if I go from 1 to 52, that's multiplying by 52. If I go from 12 to my run, I need to multiply by 52 as well to continue that gradient. So that means the run is going to be equal to 12 times 52, which is 624 centimetres. So that's our answer to part A. It says how far from the platform the ramp would need to start if it is to reach the top of the platform. That's one way we can do it. That's one way we can do that first question. The second way we can do it is we can use a Cartesian plane to describe our problem. if we use a Cartesian plane to describe our problem, then we can say our point on our Cartesian plane here is going to be the origin is going to be the start of our ramp. So our ramp is going to go up in this direction. Okay. Now we know our ramp has to reach 52 centimeters high, so it's going to be at some point here, x 52. Oh, sorry. Yep, x 52, because the y value is 52. We need it to be 52 centimeters high. 52. We know the gradient needs to be 1 over 12. So once again, we know rise over run equals 1 over 12. We know the gradient, rise over run, is 1 over 12. So the rise is equal to our difference in our y values, y2 minus y1 over x2 minus x1. And so that means, if I'm taking it as the origin, that means my value for x1, y1 is 0, 0. So I'm left with 52 over x. 52 over x, the x point. 1, and that is 1 over 12. So once again here, I can see going from here to here, I need to multiply by 52, multiply by 52. So that means my x coordinate is equal to 52 x value is 12 times 52, which is 624 centimeters. Now I haven't really answered that question even if I've just written x equals 624, because the question asks how far from the platform the ramp would need to start. So the platform is at that level. We need to write a sentence. So the sentence, I'm not going to write it, but you would need to write a sentence something like the platform, the ramp needs to start 624 centimeters from the platform. That is a sentence that you would need to write to answer that part A. Now part B, depending on your first answer, could be answered in two different ways. You can answer part B by looking at your triangle that you've drawn, the diagram that you've drawn, realizing it's a right angled triangle, seeing this is 52 and this is 624, and you need to find the length of the ramp here, c. We know that c squared is equal to a squared plus b squared. We always write the formula. That's 52 squared plus 624 squared. So c is going to be the square root of 52 squared plus 624 squared. And if you plug that into your calculator, you'll end up getting something like 626. You get 626.2 centimeters. And that's the length of the ramp. Once again, you would need to answer in a sentence the length of the ramp, therefore the length of the ramp is 626.2 centimeters. I wouldn't be going to many more decimal places than that, because otherwise you're getting into super inaccurate territory. There's no way to know that you could be possibly measure that ramp that accurate to the nearest millimeter. It's a very long ramp. The way you can solve this if you completed using the different strategy that I had before, which is graphing it on the number plane, is by using the distance formula, which is essentially using Pythagoras' theorem. So using the distance formula, you would be able to substitute in the values that you had for the bottom of the ramp and the top of the ramp, and finding the distance between those 2 points. Now question 5 is quite challenging. It needs a lot of unpacking. We've got different buoys. We've got a course for a yacht race, and the buoys are positioned at -3, -4, -1, 3, 9, 8, and the last buoy, we don't know where it is yet, at XY, we don't know where it is. The race begins at the middle position, at the origin, proceeds to A, then to B, then to C, then to D, and then back to the starting point. The judge's boat must be placed in the middle of buoys A and C, and in the middle of buoys B and D. What we need to do is firstly find out where the judge's boat is, find out where buoy D is, and then look at the greatest distance. It says you can use the graph paper provided to aid you in your response. If we have a look at using the graph paper to aid us in our response, we can plot the different points. We can plot here the origin, O. We can plot our first point of our buoy, A, -3, -4. So -3, 1, 2, 3. Our buoy A is right here. Our buoy B is at -1, 3, -1, 3 here. That's our buoy B. Our buoy C is at 9, 8. So 9 here. And then 1, 2, 3, 8 here. That's our buoy C. And we don't know where buoy D is. We do know that the judge's boat is in the middle of A and C and in the middle of B and D. So we know where A and C is, and we can find the midpoint of those two boats. So the midpoint, or the judge's boat, is going to be the middle of points A and C. So that means if I take the x value of A and the x value of C and divide them by 2 and do the same for the y value of C, divide by 2, I'm going to be able to find the points. So the A value of the x value for A is -3, for C is -1, divide by 2. The y value for A, oh sorry, that's B, that was close. The x value for C is 9. The y value for A is -4. The y value for C is 8, divided by 2. And we get the location of the judge's boat. So that's going to be -3 plus 9 is 6 over 2 is 3. -4 plus 8 is 4 over 2, which is 2. So the judge's boat is going to be at 3, 2. So we've got our position for our judge's boat now. It is going to be at position 3, 2, this point. Now we can see if our judge's boat J is here, that the judge's boat needs to be in the middle of B and D. So point D is going to be somewhere around here. It's going to be somewhere around here, and we can work backwards to determine what that is. We can also think about our third problem. The third problem, part C, because we've drawn our diagram, we can see we start at point O, go to A, go to B, go to C, back to D, which is going to be somewhere over here, and then back over to point O, our origin. We can already pretty much see that the shape that we're going to be making, if it's going to be a point that's right in the middle, is a parallelogram. We can see that our side length that's going to be the longest is probably going to be BC. BC is probably going to be the longest side, because AB, I can see from my diagram, is much shorter. CD is going to be parallel and is going to be the same length there, and AD would also be the same as BC. But because AD isn't going to be found, we don't have AD. There's no point in the competition where we go between A and D. We go straight from D back to O. Those, both O to A and O to D, are going to be much shorter. Okay, so we can already kind of think that length BC is probably going to be our longest length, but we can use maths to work that out later. So our judge's boat is at 3, 2. Let's have a look analytically where our buoy D is going to be. Okay, so buoy D is going to be halfway through, our judge's boat is going to be halfway between buoys A and D. We know that our judge's boat J is going to be at point 3, 2. Our midpoint between points B and D is going to be equal to 3, 2. That's their judge's buoy. So midpoint B and D is going to be x of B plus x of D over 2, and y of B plus y of D over 2. That B looks a bit funny. B. All right. So our x value for B is -1 plus xd. over 2. Our y value for b is 3 plus yd over 2. So in order to work these out now, I can work them out separately. So I can see negative 1 plus xd over 2 is going to equal 3. That means negative 1 plus xd is going to equal 6. That means xd, if I add 1 to both sides, is going to equal 7. So that means xd is equal to 7. We can, and then that means that 3 plus yd over 2 is going to equal 2. 3 plus yd equals 4. yd must equal 1. So we can say, therefore, point D is going to equal 7, 1. For our last one, finding the greatest distance the yachts travel between two buoys. I've already said that the greatest distance is probably going to be between B and D. So to find that distance, the distance between B and D, it's going to be equal to the square root of xb minus xd squared. Sorry, not B and D, B and C. Not B and D, B and C. Plus yb minus yc square root. So the greatest distance here is going to be our xb is negative 1 minus xc is 9 squared plus yb is 3 minus 8 squared, which is going to be equal to negative 10 squared plus negative 5 squared, which is equal to the square root of 125, which is equal to 11.18. Then we answer with, therefore, the greatest distance travelled is 11.18 units.